Let's sketch the graph of a Lambert W function. And we start with this function because the W function is the inverse of this function. So when we have this graph, we can have the graph of a W function. Now for this particular function, we have some basic properties that f of a 0 is 0, right? When x equals to 0 is 0. When x is approaching to infinity, x to the x e to the x is approaching to infinity. Now when the x approaches a negative infinity, x to the e to the power of x, and we have to work out a little bit. The limit goes, x goes to negative infinity, e to the x. This is infinity, this goes to 0. Therefore, it's indeterminate. We can do this, right? This is x over e to the negative x. So this goes to infinity, negative, negative. This is infinity, this is infinity. Therefore, we can use L'Hopital's rule. So this goes to infinity, negative. This is 1, this is negative e to the negative x. So when this is going to infinity, therefore is equal to 0. That means our limit is equal to 0. Yeah. Now then we take the derivative of f with respect to x. That will be the derivative of this function with respect to x, which will be e to the x plus x e to the x, right? Which is equal to e to the x and 1 plus x. And when this is equal to 0, it means that x equal to negative 1. Well, we try to find some critical points. Then we can sketch the graph. Now, the second derivative will be the derivative of this one, take it twice, the derivative, which is the derivative of this one, which is e to the x plus e to the x plus x e to the x. So this one is equal to e to the x and 2 plus x. When this one equal to 0, that implies x equal to negative 2. Well, which means that we have two critical points. One is x negative 1, and we put it there. We can find a y value, which is equal to negative 1 over e. The other one is when x equal to negative 2, and you put it there, we can find a y, which is equal to negative 2 over e squared. So these two are critical points for this graph. Then I make a table which summarizes our feature graph, which is x. We have 2 points. One is a negative 1, one is a negative 2. Start with negative 2 and a negative 1. And we have a y derivative, y second derivative, and the y. This is a y. So these two critical points divide the whole interval into three subintervals. One is from -1, -2, -2. The other one -2 to -1, and the other one -1 to infinity. While during this interval, my first derivative is this. So in this interval, the first derivative will be negative. At -2 is negative. In this interval is negative. When x is less than 1 is negative. At -1 is 0. When x is greater than -1, it would be positive from this one. Now this is the second derivative. Second derivative in this interval is negative. At this point is 0. When x is greater than -2, positive. Now then we have the shape of the curves. At a -2, the y is a -2 over e squared. At a -1 is -1 over e. Okay, now this is these two graphs summarize the shapes of the curve determined by the derivatives sign. When this is the way. When second derivative is positive, first derivative is negative. This is the shape. Second derivative is negative, first derivative is positive. That is the shape of the curve. Second derivative is negative, positive. First derivative is 0, which is the minimum. Second derivative is negative. First derivative is positive. This is the shape of the curve. Second derivative is negative. First derivative is negative. That is the shape of the curve. Second derivative is negative. First derivative is 0, which is maximum. So it's very good, summarizing the shape of curve determining by the signs of the derivatives. So second derivative is negative. First derivative is negative. So that's the shape. That's the shape. Second derivative is positive. First derivative is negative. This is the shape. So that's the shape. Both positive, positive, positive. That is the shape. Okay. Obviously, this will be minimum. This is a point of inflection. See, change the shape. Now, based on this, we can sketch the graph for this function. Okay. This is our coordinate system. This is 0. We have two critical points. One is a -1. One is a -2. -2. -1. -1 for this is a -1 over e. So this is the point. This is the point. This is the point, the curve passing through. And -2 over e squared. This will be somewhere here. -2 over e squared. Yeah. So this is the point. This is the point. And also this is the point, passing through 0. Okay, very good. X is approaching to 0 when x approaches to negative infinity. Obviously, the y-axis is my asymptote. The shape is this. From infinity to this point is this shape. So that's the point. This is the shape. Okay, that's the shape. And this is the asymptote. And from this point to that point, this is the shape. So that's the shape. Right? This is the shape. Yeah, that's the shape. This is the shape. And after this point is one shape passing through this. So it's like this. Well, sketching is roughly this. Okay. So this is my curve of this function, right? Y is equal to x e to x. Very good. Now we can sketch the inverse of this function. So we get a W function, the graph. To sketch the inverse, we draw this line, right? Y equal to x. So the inverse function just mirror image of this curve. The mirror is this. So this point will be there, mirror image, right? So this will be negative 1 over e. And this is a negative 1. That is the image. And for this image, it will be somewhere here, right? Somewhere here. Yeah, this will be negative 2. This point is a negative 2 over e squared. Sorry, the 0 is here. Very good. Now we can sketch the curve, right? Sketch the curve. It's a symmetrical. So the shape is, well, it's, something like that. Well, that is the image in this mirror for that one. And then this is the image of this one. Then that will be the image of this. Wow, good. So this is the image in this mirror for this function, which is the inverse of this function. That is our Lambert W function. And we call this part W sub 0, what is it called? The principal branch. And that part is W sub negative 1, which is the lower branch of the graph of a W function. Here, this is a very nice, very nice curve. Now, from this graph, we can know many, well, not many, but we can know several things, which is quite important. For example, the domain of a W function is from minus 1 over e to positive infinity. The range will be from minus infinity to positive infinity. Right? Yeah. And what else? Well, when x is positive or 0, so we will have this function, W function has a one real solution, right? Yeah. See, the picture can tell us many things, which is a picture worth 1,000 words. You know, many properties we can see from the picture. When x is between minus 1 over e and between 0, right? Then our W function has two real solutions. This one is a one real, this one is a two real solutions, right? When x is less than 1 over e, then this W function has no real solution. It has only positive, the complex, because beyond this point, there's no corresponding point for W function. So it must have complex solutions. Yeah. What else? Well, W0 is 0, right? And W minus 1 over E is equal to minus 1, and so on. Right? So this graph really helps when you use the W function to solve equations. I think the pictures sometimes it's much better to memorize some important features. Okay, I hope this graph it helps for you to use the W function. Well, today our main thing is that how to get this curve. That is today's objective, to use the steps here, to use the table, and from this curve we get an image of the inverse of function, and so on. Well, I hope you like it.